Okay boys, press pause while you read through this question. Now the first thing to note is that A is a 2 by 1 matrix. Okay, and B is a 2 by 2, 2 rows and 2 columns. That means that X must be a 1 by 2 matrix, mustn't it? Because those numbers must match, and the outer numbers are telling us the dimensions of the resulting matrix, so it's going to be 2 by 2. Okay, that means we can set up our little problem in this way. We can say that AX, so what was A? It was, let's just write AX, equals -2, 1 times some matrix like that. We don't know the values yet, so we're just going to call them A and B for the moment. And that's going to equal our B, which is -10, 6, and 5, -3. Okay, what happens now? Well, we just multiply out A and X and see what happens. So remember, it is row by column, row by column, row by column, and then row by column, row by column. Okay, so this is what you're going to get. You're going to get that equaling, now -2 times A is -2A, and -2 times B is -2B. And then we get a bit of luck here, because 1 times A is A and 1 times B is B. And so that's going to equal B, oops, that's -10, isn't it? 6, 5, -3, like so. And then what we can do is simply rely on the fact that, as shown here, that A is 5 and B is -3. Okay? Now, how does that help us? Well, it helps us substitute values for A and B in there. So we can say from that therefore X equals 5 and -3. And that's our answer. Now you can confirm that by just multiplying A by X. So A by X, and your answer will be as shown there for B. Now the thing we're going to want to do here first off is find the value of A squared and then see what happens. Okay? Alright, so here we go. A squared, let's write it out in full. So 2, 1, -1, 1. We just times it by itself, of course. So 2, 1, -1, 1. And row by column, isn't it? So we go 2 times 2 plus 1 times -1. So the answer to that, of course, is 3. And then row by column again, so 2 by 1 is 2 plus 1 times 1 is 3 again. And then the second row, we go -1 times 2 is -2 plus 1 times -1, so it's -3. And finally we get -1 times 1 is -1 plus 1 times 1 is 0, like so. Okay, so that's A squared, isn't it? Alright, so what we know at the moment is that, let's reduce this a bit, is that A times A squared, so that's 3, 3, -3, 0, plus BA, so it's B and the original matrix A, which is 2, 1, -1, 1, must equal matrix B, which is -2, -4, 4 and 2. Okay, just squeaks in. Alright, what are we going to do here? Well, what we can do is, we know these scalars A and B can be brought inside the matrix bracket, so let's do that. Therefore, 3A and 3A there is equal, -3A there and 0 there, plus 2B and B there, what have we got? Negative b and b there is going to equal negative 2, negative 4, 4 and 2. Okay, let's move some of this upstairs a bit and see what we do. Now, what can we conclude from all this? Well, a couple of things. If you're clever, if you look around a bit, you can see a 0 there, they're always worth looking for, and a b there. So that really means, doesn't it, that 0 plus b must equal the corresponding cell in B is 2 over here. See that? That plus that must equal that. Well, that's pretty good value for money because we just found the value of B. Oops. Therefore, B equals 2. And then we find an equation that suits us, suits our purposes, to find a value for A. So, I mean, there's any number of ways of doing this. So we can just pick maybe this cell here and its corresponding cell there and conclude that that plus that equals that. So let's just write that down. Therefore, negative 3a plus minus b is minus b equals 4. And substituting b equals 2 into that equation, we get, therefore, negative 3a minus 2 equals 4. And therefore, negative 3a equals 6, adding 2 to both sides. Therefore, a equals negative 2. Okay, so they are the values of our scalars, a and b. And we should write that out neatly, but room's a bit short at the moment.